Hi everybody, this is Mrs. Ellsworth, and what we're going to be doing today is we're going to be taking some of these expressions that we've been talking about, and we're going to be creating tables and graphs with them. So let's go ahead and take a look at the first one. Number 2 in your homework has got this thing going on. Bob spent 5 more than 3 times. So we got times 3 plus 5. And I put it in that order, not the order that it's written, because you must always do multiplication first. Okay? We also, so this is times 3. So it's really times whatever's in this first column, which is always x. So it'd be 3x, 3 times x, plus 5. Okay? So I'm going to go and stick in 2. 3 times 2 plus 5. So this is going to be 6 plus 5. That's going to equal 11. So here we go, 11. And you got to draw out these function tables for your homework, please. I may ask for 1 or 2 spots, or else all of the spots when I do your form sheet tonight. Okay, let's keep going on this. We've got 3 times, what is the x that we're going to be doing now? It's going to be 4 plus 5. So that's going to be 12 plus 5, which is 17. Okay, then we've got 3 times 6 plus 5, and that's going to equal 18 plus 5. That's going to be 23. Okay, and we've got 8 is next. Oh, I should be writing these in here, sorry. And then 8 is next, so we got 3 times 8 plus 5. So it's going to be 24 plus 5 is going to equal 29. So there it is. So that's how you do your homework. I may ask for you to write down all of these in this column, and then I may not. I may ask for just one of them. What is the value for 8? Or, or I may ask for the domain and range, because we've got to talk about that next. So your x values are always the domain. So what is the domain? Here's a new term. They are always the x values. They are always the x values, and they are also the inputs. Okay? The y values. Okay? Those ones are called the range. And again, whatever inputs that you have, they affect the outputs. So whatever one I put into the formula, they affected my outputs. And that's the same exact thing that it is with graphing and all those. Whatever your x values are or your domains, they affect the shape of your graph. So these ones are the y values, and they are the outputs. And you may recognize some of these names here from when you did function tables in 6th grade. So we've got to name our domain and our range on each one of these. So let me get an eraser here. Okay, and let's name our domain and our range in this problem. Okay, so here it is. The domain is, and we're just going to put these in parentheses. Okay, and this is going to be a 2, 4, 6, 8, and you don't go any further. You don't assume anything more than that. That's it. When I punch these into the computer, I'm not going to put any spaces in them. Okay, and you don't have. You can put spaces in there if you want to. I'm just telling you how I'm going to punch it in there, and it'll be correct if you don't have it exact spacing like I do. But you just got to have those numbers, don't you? Okay, so the range is going to be the numbers 11, 17, 23, and 29. And I want to tell you also a little check trick that I know. Notice this goes up by 6, 6, and 6. They should keep going up at the same amount. If these right here keep going up the same amount. Okay, these ones all went up by 2. These ones right here went up by 6. Okay, so it's just something to check your work and make you feel a little more confident about what your answer is. Okay, so that's the type of problem that you'll have with 1 and 2 and, oh wow, four more of them right there. Okay. Okay, so let's now go and practice one like 3. Okay, let me erase some stuff here. Okay, so in number 3, we've got to do a couple of different things. Okay, write an equation that can be used to find the number of ounces in any number of pounds. So we're going to write an equation. Any number of pounds we'll call P. Okay. Okay, so we're going to call pounds, we're going to call that just P. Okay, and so here's the problem. There are 16 ounces in 1 pound. So they're saying after you add each pound, 2 pounds, 3 pounds, all those, what is going to be your equation for that? So we're going to have 16 times P equals, what would it be? Number of ounces? I don't like writing O's, so I'll just put it, since it's OZ, I'll just put a Z. Okay? You can put any variable in there. You can put any variable in there and it's going to be correct. I'll just have to go through and check it, so that's okay. Remember, 16 times P is written as 16P. You can put a times sign in there, but you need to eventually get to where you're just writing 16P. Okay? Make a table to find out the number of ounces in 5, 8, and 11, 13 pounds. So here we go. We've got our table right here. We've got a P value here and a Z value here. So in our expression portion of the equation is always what the first one is here. And we've got to do 5, I call these T-charts also, 11 and 13. These ones do not go up at a constant rate, so you wouldn't be able to check it like we did over here. Okay, so we're going to go and take this times 16 for each one of these. And so go ahead and do that. I'm going to use a calculator and I'll be right back. Okay, I just did the calculations for this, so you can look at my calculations, and here they are. But the neat thing about this now is that each one of these actually makes an ordered pair. Okay, 5, 8 is an ordered pair. Okay, because it's really an X and a Y value like we talked about up here. Okay, then 8, 128, and then 11, 176, and 13, 208. Okay, so those are ordered pairs. That helps us in graphing this situation. Okay, so I'm going to now get a graph ready here. Okay. Let me erase some of this. Oh, I'm just going to go down. Here we go. Oopsie. Okay, so here we're going to go ahead and graph these ordered pairs. Okay. By the way, this right here was the answer for B. And now we're going to do the answer for C. So all we need to do is just go and set up a nice little table here with an X and Y axis, both the positive values only. And so what we're going to go and we're going to plug in here is we're going to plug in the pounds. Okay, and then we're going to plug in the ounces. Okay, now we got to go up to a big number, so I'm going to do mine by 50s. Okay, here's 50, 100, 150, 200, and then 250, and we don't need to go any further. I really stretched this out, sorry about that, but it's good enough. Okay, so what could I do to have answers on your form for this? I could have a couple of different graphs out and you'd have to go and check which one is correct. Okay, so we've got our first value is 5 and 8, so oh boy, that's going to be tiny. And oh wait, I better come up with some things on here. We need to only go to 13. So I'll go by 2s. 2, 4, 6, 8, 10, 12, and 14. Okay, so we've got 5 and 8. So 8 is going to be really tiny here going up. This is a very odd graph here. So such big values and tiny values here. Okay, then we've got 8 and 128. So 125 is halfway here. So I'm going to go over to 8. There we go. Okay, then we've got then we've got 11. 11's right here. And we've got 176. So right here is 150. So 176 is going to be over here. So we'll go over to 11. This isn't very straight here. I'm not estimating very well. Sorry. And then we've got 13 right here. And we're going to go all the way up to 208. So we're going to go up a little bit above 200. Okay. This should be linear. It is not, but it's okay. So here we go. Hopefully you can draw a straighter line with paper and pencil. Okay, so that's how we graph them. So you got to figure out what these values are in here by what your values are for the x and what the values are for your y. Now, if they also asked you to do the domain and range, well, why don't we just go ahead and look at another problem. Okay, I'll go ahead and do this one right here. Okay, a dog weighs 4 pounds more than a cat. Okay, so here is x, so we're going to say 4 times x is what our function is going to be here. So now we just need to plug in each x. So it's going to be 4 times 3, 4 times 6, and then 4 times 9, and then 4 times 12. Notice that these values right here all go up by 3, so we should find a nice pattern going down here too. If it's not a nice pattern, then we've done something wrong. So 4 times 3 is 12. 4 times 6 is 24. 4 times 9 is 36. And 4 times 12 is 48. Well, hey, look at that. They go up by 12 each time. That's pretty cool. Okay, it asks for you to state the domain and range of these. Okay, our domain is going to be, guess it. It's the x value, so it's going to be 3, 6, 9, 12. Okay, the range. Okay, that's going to be parenthesis. They're the y values, so that's going to be 12, 24, 36, 48, and then parenthesis. Okay, so that's how you do the domain and range. So you've got 4 more of those tables that you have to figure them out and figure out the domain and range. And then you've got 2-word problems like we did. This one's kind of cool. You have to start from a graph. And so you guys can go ahead and do that because now you can make some observations from this, from the graph. I think that this one will be offered as extra credit, and I've got more problems selected too. Whoopsie daisy. Pen. Okay, so that's it, and see you later.